All right, we're back here in section 10.1, second part here, and we're going to be looking at constructing a confidence interval for the population mean. And we're going to state the parameter. Again, the state plan do conclude. We're going to state that parameter that we want to estimate and find in the confidence level. We want to identify the appropriate inference method and check those conditions. If the conditions are met, perform your calculations. And then, of course, you want to interpret your interval in the context of the problem. So we're going to look at a couple of examples on actually doing that. As we go along here. So remember the one sample t interval, we can use the calculator to compute that as well. When the conditions are met, remember that the unknown, the confidence interval for that mean is that formula that you see there. And again, t is the critical value with n minus 1 degrees of freedom, and the c percent is the area between negative t and t is what we have there. All right, so here we go. Chapter 8, you learned that about 73% of Americans claim to have read a book in the previous 12 months. This was based on a 2016 Pew Research Center study that interviewed a random sample. Remember this, the sample size, 1520. As you read through these, always put down those key points. So 1520 is our sample size. The same study also reported that the average number of books read by the members of the sample, including those who reported reading 0 books, the sample was 12, with a standard deviation of 18. So remember those. Jot them down if you need to. We're going to construct and interpret a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. And then we're going to get on to question B. We'll get to that in just a second. So let's go on and focus on this. So once again, state, we're going to get a 95% confidence interval for mu, the true mean number of books read by all American adults in the previous 12 months. Now again, the plan part, we're going to use a one sample t interval for mu. It is random, it did state that. 10% is certainly fit there. And then our sample size at 1520 does meet all of those conditions for us to use the inference. Okay, so now we found that we had our mean and standard deviation here. We can use our table B if we want to. Now again, the degrees of freedom there gives us 1,000, and again we have our t-score of 1.962. Now again, with our technology, basically we're going to make sure to put those in. Our degrees of freedom, remember our sample size was 1520, so we're going to go one less, 1519, and again our t is 1.962. So if we do that, we do construct that confidence interval of 11.09 to 12.91. So in other words, margin of error is 0.91 in this case. All right, so we're going to conclude that we are 95% confident that the interval from 11.09 to 12.91 books captures mu, the true mean number of books read by all Americans in the previous 12 months. So there we go. That's it. That's how we do it. State, plan, do, conclude. Stuff we've done before, now applying this sense. Okay. Now in 2011, Pew reported that American adults read an average of 14 books in the previous 12 months. And does our interval provide convincing evidence that the mean is different? And our answer is yes, because 14 is not in our confidence interval. 14 is not a plausible value for the mean number of books that American adults have read in the previous 12 months. All right, so there we go. All right, so let's look at another question here. Manufacturer of high-resolution video terminals must control the tension on the mesh of fine wires that lie behind the surface of the viewing screen. Too much tension will tear the mesh and too little will allow wrinkles. Now the tension is measured by an electrical device with output readings in millivolts. Some variation is inherent in the production process, and here is the tension readings from a random sample of 20 screens. Remember that 20 is our n, from a single day's production. Okay, so we got all those things. Now we're going to construct and interpret a 90% confidence interval for the mean produced on this day. All right, so here we go. So we want to state 90% confidence interval for mu, the true mean tension of all the video terminals produced this day. The plan, one sample t interval for mu, the random. Yeah, we took a random sample of 20 screens. I think 20% is less than all the terminals. I would assume that. And looking at the large normal large sample, again, if we look at our plot, we don't see any strong skewness or outliers, so that's going to allow us to use that part. That's going to be one of those conditions we can use here. All right, now once again, to find the mean and standard deviation, you can always put that into calculator with that raw data and find that we have 306.32, and our standard deviation is 36.21. So again, our mean goes here, sample mean goes here, sample standard deviation goes there. Remember, it's our standard, it's our square root of our sample size of 20, And then, of course, we got our t-score of 1.729. That's what goes right here. So with that, we're able to then compute. And again, we could put that in the calculator as well. And again, we have our confidence interval going from 292.32 to 320.32. And that's what we get with that. So we are 90% confident that the interval from 292.32 millivolts to 320.32 millivolts, notice how we include the label, captures mu, which is the true mean tension of the entire batch of video terminals produced that day. So there we go. That's our construction on how to do that. We'll do some problems together and give you some to try as well from the assignment. Those are good problems to go through. Make sure you go through that process. Good free response questions, hint, hint, wink, wink, nudge, nudge. Okay? All right, now it's not enough just to make a graph of the data on your calculator while assessing normality. Now, again, we want to sketch that graph on your paper. And maybe you can make it on your calculator, but just make sure you have that sketch. And you don't have to draw multiple graphs, but any graph that you have, but make a sketch there to show that. So you demonstrate that. Now in Chapter 8, we learned different factors affect the margin of error. And this lesson, the same in this section as well. The margin of error decreases as the sample size increases, assuming that the confidence level and sample standard deviation remain the same. All right, now the margin of error is proportional to 1 over the sample size. So quadrupling the sample size will cut the margin of error in half. It should be the square root of n there, assuming everything else remains the same. Now again, the margin of error will be larger for higher confidence levels. Okay, so if we want to go from 95 to 99, we are going to increase the margin of error. And again, because we have to have wider intervals. So keep that in mind. And the margin of error doesn't account for bias. Remember, if there's some non-response or some other sources of bias, that margin of error does not account for that. It's only on sampling, variability, all those things that we've talked about before, and those are our learning targets. So that wraps up Section 1. I urge you to really look at those exercises. There's some good ones on 665, 9, 13, 15, then some multiple choice again on 21 through 24. Take a look at those. That gives you that practice and gets you to go through those. So, all right, until next time, I'm Mr. Bone.